didn't see you there. You're just in time. I'm about to talk about particle size and the collision theory.
Collision theory is the explanation of how particles hitting each other produces chemical reactions.
We're here to explain how the size of a particle could affect this. But let's first talk about collision theory.
Collision theory is basically the theory that states that one atom has to hit another atom in order for it to react. As you can see, there are two atoms in this example. The atom on the left isn't reacting with the one on the right because they aren't in contact. However, when they do come into contact, a chemical reaction occurs and a new product is formed.
And that is how atoms react and form new compounds.
Now let's explain how surface area connects with this.
As you can see in this animation, we have a large cube of solute in a solvent. For anything to happen, the particles have to come into contact, just like we explained in the collision theory. The atoms on the outside can only interact with the outside of the cube, and it can only interact with the area exposed to the rest of the chemicals. This exposed area is called surface area. As you can see, the surface area at this moment is rather small, and so the reaction is much more slow.
However, when we divide the cube and expose the atoms on the inside, this changes. By dividing up the cube, we have increased the surface area, as the atoms that were hidden away can now come into contact with other chemicals. They can now collide and react. The reaction is also much faster.
So that's how surface area and collision theory work with reactions.
More surface area means more room for collision, which means faster reactions.